here's a problem that should give you a mental workout on arc length. Okay, this is on page 62, section 1.2 in Dokopowski's book. This is problem 109. So Sunbelt Paper Products makes conical paper cups by cutting a 4-inch circular piece of paper on the radius and overlapping the paper by an angle alpha as shown in the figure. So I've made one of these for us. So you cut, you rotate in, you get a sort of a cone like this, and we're looking at the volume of this cone. So you can think about that, but really what we want to do is we want to think the volume of a cone has to do with the radius. So if I stuck this right in here, the radius of the circle at the top, that's R, and the height, H, right there. So somehow really what I'm working on is I'm working a lot on this triangle. Well, you can see that triangle sort of shows up in their picture right here. If I just knew this R and that H, all would be well. Because if you recall, the volume of a cone is 1/3 pi r squared h. Well, so here's the issue. We need r, we need h. Well, if I'm going to recreate those pictures from before, mine aren't quite as pretty, but there's my alpha. Now the alpha in the problem is in degrees. There's my radius. How is, and here's the wrapped piece of paper, how is this picture related to my R and my H? Now I realize the scale is quite different, but depending on the alpha, the cone might be taller or shorter. So how is the R and the H determined using this? Well, the secret is this top circle, right? So this top circle has a circumference, and we all know that the circumference of the top circle is related to that radius by 2 pi r. Well, where did the circumference of that circle come from? Well, it came from the outside of this piece. So the outside of this piece, if we think of that as C, the inside of this piece, that's the arc length related to alpha. So alpha, the arc length, remember, is the radius, 4, times the angle in radians. Well, if that's in degrees, alpha degrees, how do I convert from degrees to radians? I take alpha and I multiply by pi over 180. So this piece in here, if I was going to reduce that, would be something like pi alpha over 45. Okay, so that's this arc length. Well, the whole circumference of this circle, since the radius is 4, remember 2 pi r, the whole circumference of this circle would be 8 pi. So what is the leftover piece? It's 8 pi minus pi alpha over 45. So that's something that maybe you could combine if you wanted to, but this is the piece that we're going to work with. That's the circumference of this circle over here. Okay? So let's take that C, put it over here. So 8 pi minus pi alpha over 45 equals 2 pi r. I'm trying to solve for r, so why don't I just divide everything by 2 pi. 8 pi divided by 2 pi is 4. Dividing pi by pi cancels, so I end up with alpha in the numerator. If I'm dividing by 2, I get alpha over 90. So r, I have a nice little formula for. Okay? Now, if you want to combine that, that's probably not a bad thing. So a common denominator for r would give me r equals, let's see, I'm going to have to multiply this by 90 over 90 to get a common denominator, so that's 360 minus alpha. And you can sort of see that pretty fundamentally relating to alpha degrees, and 360 minus alpha is the other piece there. Okay, so that's my r. Well, how are r, h, and 4 related? Well, by the Pythagorean theorem, we've got r squared plus h squared equals 4 squared. So I suppose I should square all of that fun right there. Let's see, so squaring this, I'm going to think about this as being a first term and a second term. I've got to do the first term times the first term, so that's 360 over 90, that's 4 squared, plus the first term times the second term. Well, the denominator is just 90 times 90, right? Then I've got this times that, and of course when you square something you double that term, so 360 alpha, which is negative, then double it. I'll just write it as negative 720 alpha. If it takes you a little while to think through that, or you want an intermediate step, that's fine. Finally, I need negative alpha over 90 squared, so that's going to be positive alpha squared over 90 squared, plus h squared equals 4 squared, 16. Well, this 360 over 90 is 4 squared. This is 4 squared, so those cancel. And we end up with 0 there. So let me move these two terms to the other side. So I've got h squared equals, if I move this to the other side, I'm adding it now, so it's now positive 720 alpha minus alpha squared, and these have a common denominator, 90 squared. We'll just leave it as 90 squared because now what I want to do is I want to square root everything inside. I know h is positive, so I don't have to worry about the overall side. The square root of the denominator, of course, is just 90. The square root of the numerator I leave as square root of 720 alpha minus alpha squared. Okay, so I have r, I have h, and I really wanted v. So this is the answer actually to part B of the problem above. V equals 1/3 pi r squared. So r is 360 minus alpha over 90 squared times h, square root of 720 alpha minus alpha squared over 90. Now if you really wanted to, you could combine this fraction, that fraction, and the 90 squared here. But I think this is about as simple a form as you're going to get. So that's the general function. If you give me alpha in degrees, that will give you the volume. Part A, working backwards here, is asking what happens when alpha is 30 degrees. So working backwards from here, I can do that. V is 1/3 pi. Then here I have 360 minus 30, so that's 330 over 90 squared, square root of 720 times 30 minus 30 squared, all over 90. And you can punch that into a calculator or simplify as much as you want. You're supposed to round off to the nearest tenth, and you get out 22.5 inches squared. So that is how you calculate the volume of the cone using arc length.